Welcome back to another session of our maths lessons. Today we're working with circle terminology, line segments through center and midpoint. Please remember to use colors in order to understand it and to make it easier for yourself. If we start with our circle terminology, you'll see I've used lots of colors that correspond with the lines that we're using in order for you to see and make it easier. Let's start a secant, a line which cuts through 2 points on the circumference of a circle. A tangent is a line drawn from a point outside the circle which touches, you'll see it's touching the circle at only one point, called the point of contact. The tangent is always perpendicular to the radius at the point of contact. Remember, perpendicular again is 90 degrees. Say, for instance, this is our center of our circle and we draw a line, which is our radius. That will be 90 degrees perpendicular to the radius. Our diameter is a line joining 2 points on the circumference which passes through the center of the circle. Very important to remember. Diameter, radius is half a diameter, and it's drawn from the center of the circle to a point on the circumference. With this one, if you cut your diameter in half, that little section is a radius. That little section is a radius, and obviously that one is a radius. So if you can just remember, radius is half the diameter. A chord is a line joining 2 points on the circumference of the circle, but it does not pass through the center of the circle, which is there. So it does not go through the center of the circle. A major arc is this section here. So that's the biggest part of your circle. And a minor arc is your smaller part of your circle. This big section here is also the major segment. And this little one here is your minor segment. Again, this is unfortunately study work in order to know your terminology. And our center is in the middle. If we do an example to see how they will ask you the question, line segment through center and midpoint. They've given us O as the center of the circle, and they've given us that D1 equals D2, and that is 90 degrees. D lies on the chord of AB. Remember our chord? Required to prove that AD equals DB. So they want you to show that these two are exactly the same length. Construction in this case is we are going to join AO and AB. Again, use different colors to make it easy. So to prove it, again, please remember, if you give a statement, you need to say why you say it. So we're working in triangle OAD, so there's my triangle, and in triangle OBD. Then what we've worked or showed before, OA equals OB because it's the radii. OD, this one here, equals OD, it's a common side. It touches each other. And let me just do that. D1 equals D2 and they're 90 degrees. It was a given in the question. Therefore, you can say OAD is congruent. If you can remember what congruency stands for, or the little sign, is congruent to OBD. My reason, side angle side, and therefore we can say that AD equals BD because of the congruent triangles. If you need to give reasons when using this theorem to solve the riders, the reason used is line from center is perpendicular to chord. Remember, we've shown you how to work it out, and this is the reason why you can say that. If we look at the converse of this theorem, it says the line drawn from the center of a circle to a midpoint, it will be this one, midpoint of a chord, my chord is AB, it will be perpendicular to the chord. So it's given that O is the center of the circle and that AD equals DB and D lies on a chord. You can immediately go over to your statement and say, therefore D1 equals D2, and that will equals 90 degrees because line from center to midpoint of chord is your reason. I hope you enjoyed this. Just remember, you need to understand the circle terminology. Then it will be easy to understand the theorems that you work in. Please remember to go back to previous lessons if you want to recap, but I hope you enjoyed the session. Thank you.